name is Vincent and I work as an engineer here at Xavitech. In this video I will demonstrate how to communicate with a pump using the serial interface. For this demo I use a USB to UART board based on the CP2102 chip from Silicon Labs. It's to the left in this image. The logic level on this board is 3.3 volts, which means it's compatible with our pumps. The USB to UART converter is connected to the pump using our adapter PCB. To send and receive data I use this. It's a terminal program called RealTerm. So in the display tab we can set it up to display 8-bit unsigned integers so we know exactly what's being sent and received. In the port tab we will choose 9600 as baud rate and the correct port, which is 11 in our case. We will send data in the Send tab. So what I will do here is to select this option for adding a new line after sending a string of numbers. You will see how that works later on. This is our document for the serial protocol. I will not cover it all here, but you can find it on the website xavitech.com. A communication package looks like this. The first 4 bytes is the serial number together with net ID, which are used when you address a specific pump in a system with multiple pumps. These bytes are set to 0 in normal communication. The next 2 bytes is the memory address and the type of memory. And then we have the number of data bytes together with read or write. And then we have the data bytes and finally a checksum. So next let's have a look at the response from the pump. If we send a read command, the response from the pump will be the requested data bytes together with the checksum. If we send a write command, the pump will respond with 1 byte, 165 in case of a successful command and 90 in case of a failed command. So to test this out, I have created a small text document with a few commands listed. And the first one we're going to look at is the flow control command. So as you can see here we have the 4 zeros we talked about before, and then we have the address, and then we have the read, write and amount. So a 0 in the amount will correspond to 1 byte because you will always send at least 1 byte. So the 1 here corresponds to these 2 data bytes, and then the 1 here corresponds to that it is a write command, and yeah, the 2 data bytes and the checksum. The way you calculate the checksum is that you add up all the bytes, and in this case it's 491. And then you take this 491 modulo 256 to get the checksum, and in this case it's 235. So what you can do if you program in, for example, C or C++, is that you can have a variable that is 8-bit, unsigned 8-bit, and you can just let that one overflow when you add this together, and you will get this checksum value. To test these commands we need to copy these values into the terminal program. Before we send these we need to make sure the port is open, and in the display tab I forgot one thing here. It's half duplex. It means that it's showing the outgoing characters. So before we can send now we need to start the pump by applying power, and hopefully we can hear the pump, and when we send these numbers it should give a low frequency, and it does. The green numbers here are the ones we sent, and the yellow one is 165 as response, which means it's a successful command. To reset the pump to the original frequency we can just add zeros here, and this adds up to a checksum of 0. That's why you can add 3 zeros. And the pump is back to the original frequency. Finally, I want to show you the read firmware command. If I copy this and paste it into the terminal program, you can send it to the pump, and the pump responds with the checksum of the entire flash. And that concludes this video. I want to thank you for watching. My name is Vincent. Talk to you in the next one.